Hi, welcome to Mauer's Electric Corner. And what I'd like to show you today is a device called Tempo. Tempo is an stm32 based temperature logger with built-in flash, USB connectivity, LiPo battery charging, and an OLED display. And it only measures about 25 over 30 over 15 millimeters. So this project started about 2.5 years ago when I wanted to learn PCB layout rather than just doing schematics. I used to work for a company where we only used to do the schematics and we would outsource the layout. And they decided to give me one project to do the layout for. It was a really simple board. It only had like relays and an 80 mega, I think. And I really wanted to do something a bit more challenging. So I always had this like little box of mints that I thought was perfect for a project box, and I really wanted to do something with it. I thought about it a bit and I came up with Tempo. So I've been dabbling with ST Micro for a while after a friend of mine gave me a discovery board, and I really liked the platform. So the first version of the board was made with an stm32 030 micro and a DS18B20 temperature sensor, and it originally never had logging capability. It would only pull the data from the sensor and put it on the OLED display that was connected on this side. But even that was a challenging task for the micro, since the one-wire libraries that existed for ST really need a higher clock speed than what my micro could do. So essentially what I had to do was overclock the microcontroller every time I wanted to communicate with the temperature sensor. And I just immediately realized how ridiculous it was doing that. Not to mention the amount of current it pulled from the power supply. I started working on Rev 2. So on Rev 2, I immediately knew that I wanted to make it as a temperature logger rather than just something to display the temperature. So I immediately worked on it, and I wanted to do something with to get the data out. So I upgraded the microcontroller to something with that has USB connectivity, and I added an SPI flash. Other than that, I replaced the temperature sensor to the LM75, which is I2C based. And that's the board that we have right here. And now the thing that happened that on both of these boards, the power supply that I plan to use was a CR2032 point cell batteries. The ones that you can get with the built-in connectors, the JST connectors, which are just connected on the back, and then via an NCP 1402 boost converter, they would give 3.3 volts to the entire board. And unfortunately, after I finished designing Rev 2, the part got discontinued, and I had to redesign the power system. And on top of that, there was never a plan to charge the batteries, meaning that the user would have to replace the batteries every time it ran out, which could be problematic with the connector and everything. Now, setting that aside, I would like to talk a bit about the software. So during that time, I switched to True Studio, which is a great IDE, by the way. Now that ST bought them, you can get all of the features from the IDE for free if you use an ST Micro. And on top of that, I also used the MX Cube to generate all the code for the drivers. But to my surprise, I found out that it took about 85% of the program memory just to do the USB communication and initialize all the drivers and everything. Not even my code, just the drivers and the USB took about 85%, which is ridiculous. I mean, that just doesn't make sense, especially in such a tiny micro. So I went to the code of the drivers, and I noticed they did a lot of things that are not uh, essential for a single task-based microcontroller, and I had to rewrite all the drivers myself. After I did that, I managed to get the code, including my own code, not just the drivers, everything, down to about 55% of the chip, as in 55% of the program memory and about 88% of the RAM. And unfortunately, I can't reduce the RAM more, since I left the USB code as is, and it takes about 1.5K of RAM. One of the things I did to optimize the code usage was move all the fonts of the OLED display graphics library to the flash, and I modded the driver to essentially, once it tries to put an ASCII character on the screen, it goes to the flash to a known offset, and it pulls the fonts from there. That gave me a reduction of about maybe 15 or 16K of flash. That once I just tried to add the fonts to the code, immediately I would get a memory over usage, and the code won't compile. Right, so now we have moved to Rev 3. So what changed? The main reason for this revision was to add a better power delivery system for the board. And I also really wanted to include a method for recharging. I took the USB 5 volts and passed it to an MCP738030 LiPo charger, and its output is connected to a small 110 milliamp hour battery that is also connected to a Micrel 5353 linear regulator. And I tested the amount of current being pulled while the tempo is in low power mode, which is, it's recording, but the screen is off, and you can get about 40 hours of recording time out of the battery, and that's with 1 second intervals, as in every second it will log the temperature. You can see there's about a couple of milliamperes of a jump once it tries to access the flash, but other than that it keeps idle at about 2.5 milliamps. And other than that, I only changed the button and the SPI flash to a microchip part number, since, you know, Micron likes to make everything not recommended for new design every 5 seconds. Like, it's just, you count just 1, 2, 3, and another Micron part went obsolete. Also, I did this board using JLC PCB rather than the vendor. I did the 2 first boards, and not even talking about the cost, which was dirt cheap compared to how much I paid for these the first 2. The quality is actually a lot better. It was a lot easier to solder with the JLC PCB part than the originals. Without a doubt, just use JLC. Now let's go to some of the main features of Tempo. So the first thing that we can see here, this is the main screen, and it will show us a couple of things regarding the device. In the center, it shows us the current temperature that it's measuring. The sensor I have here is a bit broken. I think I overcooked it a bit, so it's showing quite a high temperature. Don't worry, I'm not working in 32 degrees. On the bottom left of the screen, you can see the amount of recordings that exist inside of the device. And at the top right, you can see a little circle indicating that we're currently recording. On the back, we have a LED that blinks every time the tempo takes a sample. Now, the tempo only has one button, and the way to interact with the device is we're using short presses and long presses. So a short press can do one thing and a long press can do another. So for example, on the main screen, if I do a short press, it will turn off the LCD and go to low power mode. and that will turn down the clock speed and then and lower the power requirements of the device. If I turn the screen back on, we can see that it keeps going. Yeah, there is a bug here that it lowers the timer values. I need to fix that, but no biggie. If we do a long press, we can open up the menu, and here we have a couple of things that we can do. First of all, we can stop the recording. So now the recording stopped, and we can, using short press to navigate and long press to enter, we can go, for example, to recording setup. Here we can choose a couple of things to do. So the first thing, we can choose the amount of seconds to wait between each sample. And here we have either 1, 5, 10, 30 or 60 seconds between samples. So I can long press and I can choose that. We can also choose if you want the LED to turn on every time it records. And the last thing right here is we can choose to delete all the recordings from the flash. And we can click exit and we go back to the main screen. Okay, now let's look at the GUI, which is written in Qt over C++. Basic stuff here. Once you click the connect, you'll see that the USB device pops up as a COM port you can connect to. And once I click connect, you'll see it's connected with this symbol here. Now here we can download our recordings, and once I click recordings, it will poll the device for all of the available recording descriptors in the flash. And here we can select one of them and download it. For example, I'll select this one, click download selected. I can choose a file name to save it as. Let's go with, for example, test1. And it will download the samples right now. And once it's done, we can view the file. And we can see that it sets the samples up as a CSV, where one column is the temperature and the other column is the amount of seconds passed. Other than that, from this GUI we can set the device to update mode, which will allow you to update the microcontroller via the DFU protocol. And that's about it. So now what? Well, I can't just put this project to bed yet. Unfortunately, there are still some stability issues and some bugs and quirks I would like to fix before I'm done with it. I would also might want to do another revision of the board, perhaps to swap out the temperature sensor to the HDC 2010, which also does humidity, but it costs twice as much, so it might jump the price a bit more than I want to. But I'm not sure yet, because I haven't checked the prices for production of 100 at least. And I checked eBay for USB temperature loggers, and there are quite a bit, and my calculated price might be even lower than that, so there might be a potential to sell a couple of them, but I'm not sure if there is even buyers for something like this. If you know any market that will actually need some of these, just let me know. And it feels that, you know, it's been 2.5 years that I've been working on this project, and it seems quite long for something so simple, and I would agree. I mean, but it's mostly my fault, since I didn't really give it the weekends. Working a full-time job and doing other things, you don't really have the time to spend on your own projects. But not all is lost. I mean, I'm actually really happy that that it took that much time, because I did learn a lot from the process, not just in PCB design. And I found out about this language that I wanted to work with, which is Qt. Because on the one hand, I wanted something that was simple to work with, but I also wanted something that will be cross-platform, and Qt just answered all of those. and I will try exploring the language a bit more because there's so much more to learn about it. I can go a lot more advanced, and I would like to try that. Anyway, if any of you are interested in this project, you can check out the Git, where you can find the GUI and the PCB firmware, and also what I use to download the fonts to the Flash as reference. Also, I would like to talk about this channel. I started this channel as a way to show my projects to the world. I have a lot more projects planned, just waiting to get them out as soon as possible. So if you like this video, please subscribe, and hopefully I'll upload more content that you'll enjoy. Thanks for sticking by. Bye.